Welcome to the training on the assembly and test of a BOP. After this training, you'll understand the purpose of the BOP, you'll cover compliance requirements associated with the BOP, you'll review the process guidelines such as breakdown and assembly, testing, and operations, and then finally, you'll learn how to complete operations with delivery, logistics, and paperwork. Let's start with a look at the purpose of the blowout preventer and why it's a critical piece of equipment. Anyone wanting to be well versed in the oil and gas industry must understand the critical role a blowout preventer or BOP serves. Understanding each component of a rig safety system means understanding how they work together, as well as their individual contributions for efficient and safe operation, as well as injury prevention. Essentially, a BOP shuts or seals the surface from uncontrolled pressure in the well bore. There are several features of a BOP that play different roles, but the main function of the equipment is to secure the well bore in the event of a kick. A kick is an unscheduled or unwanted entry of water, gas, or oil into the well bore. If a kick is not controlled, it can become a blowout, which is catastrophic. A blowout is the uncontrolled release of crude oil and/or natural gas from an oil well or gas well after pressure control systems have failed. If there's a source of ignition, this can result in a catastrophic fire or explosion, which can cause loss of life, loss of equipment, or loss of natural resources and environmental impact. Due to improvements in technology and well-controlled techniques, as well as training, blowouts are not a common occurrence in the modern oil field. The primary means of pressure control is weighted fluid, also known as mud, but if the fluid density is not adequate or fluids were lost to the formation, then there's still a significant risk of a well blowout, which is where BOPs become a critical solution. In 1924, the first successful blowout preventer, or BOP, was brought to market. The BOP is attached to the wellhead and can close in the event of drilling into high-pressure zones. As technology has developed, BOPs have become a standard piece of equipment. Let's take a look at the different types of BOPs that are used. An annular BOP, commonly referred to as a high drill, sits on top of the stack and is a type of BOP that can close around the drill string, casing, or even a non-cylindrical object such as a Kelly, and uses the principles of a wedge to shut in the well bore. It has a donut-like rubber seal, known as the elastomeric packing unit, reinforced with steel ribs. Annular preventers have two moving parts, a piston and a packing unit, which makes them simple and easy to maintain relative to ram-type BOPs. A ram-type BOP is similar in operation to a gate valve, but uses a pair of opposing steel plungers, known as rams, which extend towards the center of the well bore to restrict flow or retract open in order to permit flow. The inner and top faces of the rams are fitted with packers, elastomeric seals, that press against each other and then against the well bore and around the tubing running through the well bore. Outlets at the sides of the BOP housing, or body, are used to connect choke and kill lines or valves. Hydraulic BOPs can be outfitted with several types of rams. Pipe rams close around the drill pipe, restricting flow between the outside of the drill pipe and the well bore, but do not obstruct flow within the drill pipe. Variable bore pipe rams accommodate tubing in a wider range of outside diameters than standard pipe rams, but typically with some loss of pressure capacity and longevity. It should be noted, a pipe ram should never be closed if there is no pipe in the hole. This can damage the ram and cause it to fail when it is actually needed to be deployed. Shear rams are designed to shear the pipe or cut the pipe in the well and seal the well bore simultaneously, and has steel blades to shear the pipe and seals to seal the annulus after shearing the pipe. Blind shear rams are intended to seal a well bore even if the bore is occupied by a drill string, by cutting through the drill string as the rams close off the well. The upper portion of the severed drill string is freed from the ram, while the lower portion may be crimped and captured, hanging the drill string off of the BOP. When you hear the term BOP stack, it's referring to a combination of different types of BOPs and RAM configurations required to adequately address the wellbore conditions for a given well. BOP stacks frequently utilize both types of BOPs, typically with at least one annular BOP stacked above several RAM-type BOPs. In this section, we'll cover breakdown and assembly, as well as testing and operational requirements. You'll begin by placing the BOP in the wash bay and cleaning it to remove any grease or oil inside the body, as well as on the outside of the BOP. Break down the BOP and visually inspect the top seals and ram packers for damage. Replace all damaged components with recommended parts by the manufacturer. Upon completion of the visual inspection, you'll reassemble the BOP with a new door gasket seal. Visually inspect the hydraulic connections and repair or replace if necessary. Proper lifting equipment shall be used to place the BOP on the test stump. Now you're ready to pressure test the equipment. During testing, the crew that will be taking possession of the BOP and ultimately delivering it to location shall observe and verify that the pressure test is taking place with a signature or initials on the test chart. If a member of this crew is not available, then a qualified member of dispatch will assume this responsibility and also verify with signature or initial on the test chart. Should a member of dispatch be unavailable to observe and verify the test, a qualified member of management will assume this responsibility. Prior to testing the BOP, all personnel shall be removed from the area. If the test bay has doors, those doors should also be closed. Test pressure shall not exceed 5,000 psi or 10,000 psi, depending on the equipment being tested, without management approval. Test pressure should be established either by estimating the working pressure or established by the customer's specifications. Ensure the closing unit is properly configured for the proper testing procedure for high and low tests, and proper sized bolts have been used to make up the BOP on the test stump. Place a test plug or mandrel inside the BOP body to match the pipe ram size. Ensure the test plug is manufactured and not a homemade test plug or mandrel, as seen in the picture to the right. Fill the cavity with fresh, clean water and pressure the closing unit to 1500 psi. Begin the low pressure test by closing the BOP rams around the test plug or mandrel and pressuring the system to 250 psi, holding it for 5 minutes. Monitor the chart recorder for any drops in pressure. Check both hydraulic and water test lines. If no pressure loss is observed, proceed to the high pressure test. Begin the high pressure test by pressuring the system up from 250 psi to the correct test pressure. Hold the test pressure for a minimum of 5 minutes. Again, continue monitoring for any pressure drops, and do not exceed any limited working pressure of any component in the system. Check the system for any leaks overall, but especially on connections, the closing unit, or hoses. If no leaks are observed, release the BOP pressure to 0 psi. Once pressure is at 0 psi, remove the test plug and close the blind rams. Now you'll test the blind rams by repeating the exact sequence that we just did. Once you've successfully tested the blind rams, release all pressure from the BOP cavity and hydraulic hoses. Remove the BOP from the test stump using proper lifting equipment. Drift the BOP cavity with proper outside diameter drift to verify the inside diameter is clear. Collect the test chart and place the original on the BOP for verification of the test to the customer. But what happens if we fail to be able to get a pressure test to occur? A failed pressure test will require additional steps to be taken to ensure the equipment is safe and operational. If the equipment fails the pressure test, the equipment shall be broken down and rebuilt prior to retesting. Continued failed tests will result in the equipment being quarantined, and a non-compliance report will be initiated as part of Wildcat Oil Tools' quality management system. Additionally, chamber pressure tests shall be performed and charted when the equipment is replaced, repaired, remanufactured, or annually, whichever occurs first. Open and close hydraulic operating chambers shall be hydro-tested to the working pressure, typically 3000 psi, for a period of 5 minutes. Another type of test that is required is magnetic particle inspection, or MPI, which is a non-destructive testing process where a magnetic field is used to detect surface and shallow subsurface discontinuities or cracks. Magnetic particle inspection shall be performed annually on the shear ram blades, shear ram blocks, and blade retention bolts. Well-bore hydro testing must be conducted on the equipment when it is commissioned and annually thereafter. During testing, ram blocks shall be engaged and hydraulic closing pressure shall be vented. Test all components first to a low pressure between 250 psi and 350 psi, to be followed then by a high pressure test. Any pressure above 350 psi will be bled to 250 prior to the high pressure test starting. If the initial pressure exceeds 500 psi during the well-bore hydro test, the pressure shall be bled back to 0 and the test shall not be reinitiated. This higher pressure can cause the system to remain sealed after pressure is lowered and misrepresent a low pressure condition. Test pressure tolerances above the rated working pressure, RWP, shall not exceed 5% of the rated working pressure or 500 psi, whichever is less. Pressure-containing components shall be tested following the disconnection or repair, limited to the affected component. Valves intended to seal against flow from both directions shall be tested from both directions. Check valves installed in the kill line shall be low and high pressure tested from the wellbore side. In addition to these tests, the BOP stack, choke, and kill equipment shall be inspected at least every 5 years in accordance with the maintenance system. Individual components and subassemblies may be inspected on a staggered schedule. Inspection results shall be verified against the manufacturer's accepted criteria or the equipment owner's acceptance criteria if the equipment owner collects and analyzes condition-based data and performance data to justify their criteria. Before sending the BOP out, a copy of the test chart shall be approved and filed with dispatch and management. Part numbers and other applicable data for elastomeric components or rubber goods shall be documented on the test chart. When the BOP is returned to the shop from its job, the BOP shall be removed from inventory and placed on a work order/repair tag for inspection. Once it's placed on the work order/repair tag, this process begins again. Let's finalize this with a look at delivery, logistics, and paperwork. Begin the delivery process by ensuring all pressure is bled off of the system and all return valves and chokes are fully open. Pre-trip check trailers and trucks to verify lights and brakes work and all fluids are at their proper level. Prior to loading and unloading, the Job Safety Analysis or JSA on unloading and rigging up the BOP shall be reviewed. Load the BOP onto the trailer or trailer mounted accumulator and ensure there is no pressure on the system. Complete all appropriate resumes including any reports on the condition of the BOP and accumulator. Document all part numbers and other applicable data for elastomeric components or rubber goods on the test chart. The delivery ticket shall be signed by the company representative. Upon return of the BOP, complete a work order/repair tag for inspection and have the manager sign off on it.